Hello. Hello. Am I audible and is my screen visible? Can anyone please let me know? Hello. Am I audible? Someone please confirm in the chat if you can hear me. Okay, thank you. So good evening everyone. Welcome to this NPTEL live session for the course Deep Learning IIT Ropar. This is my 12th live session for week 12 content. So in week my name is Learning-IIT. I'm a PhD scholar in the Department of Computer Science and Engineering at IIT Kharagpur. So in this live session we will discuss some practice problems on week 12 contents. In week 12 some encoder decoder architectures and attention mechanism were taught. So we will look at some practice problems on these topics, and if you have any questions or queries regarding these topics, you can ask me during this session. So we will start solving the practice problems first, and after that, if you have any other doubts or queries, you can ask me. So this is the first question. If you need to design a model for textual entailment from the text, then which of the following steps will you choose? So more than one option may be correct in this question. CNN is used to encode the text, CNN used to decode the text, RNN is used to decode the text from the encoding, RNN is used to encode the text, RNN is used to encode the text and decode the text. So you can write your answer in the chat. Arvind Vishnu Bhatla says option E, which is RNN used to encode the text and decode the text. Okay. Anyone else? So the correct answer in this question is option E, that RNN is used to encode the text and decode the text. So in this task of textual entailment, so in this task, input is text and output is also another text. So if the input is text, so the encoder has to use RNN. So because text data needs to be fed to the RNN, CNN cannot comprehend text data properly, cannot process the text data properly because it is a sequential input data, and the output is also a text data. So the output should also come from RNN. So decoder should also contain RNN. So that's why RNN is used to both encode the text and decode the text data here. So option E is the correct answer. Now moving on to question 2. If you need to design a model for video captioning, then which of the following steps will you choose? There are 4 options. CNN and RNN is used to encode. Option B says RNN is used to decode. Option C says only RNN is used to encode, and option D says only RNN is used to perform both encoding and decoding. More than one option may be correct in this question. Arvind Vishnu Bhatla says option A. CNN RNN is used to encode. Any other answers? The correct answers are A and B, so two options are correct in this question. One for the encoder part and another for the decoder part. So in video captioning task, so the input is the video, and video can be thought of as a sequence of images. So a video is like a sequence of frames or images, and that goes as input to the encoder, which has to be first contains a CNN layer, because these are all images. So CNN is first used to process those individual frames, then that goes through one RNN layer, because it is a sequence of frames or images. Then the processed frames from the CNN goes as input to the RNN for the final encoding. So the encoder contains both the RNN and CNN. First the CNN processes those individual image frames, and then RNN finally processes the sequence of frames to produce the final encoding vector. And for the decoder part, for video captioning, the output is a sentence or a text. So the output is a sequence data. So for that we only need to use RNN. So for decoder part, so after this this part is encoder. Now for decoder we just need RNN, which will output the caption for the video, which is text. So RNN is sufficient to predict the text captions for the videos. So this part is decoder. So decoder contains only RNN, but the encoder should contain both CNN and RNN, because it's a video captioning. If it was image captioning, then we don't need CNN part, but RNN part. But as it is a video, so we have a sequence of frames or images. That's why we also need the RNN part here. So option A and B, these two options are correct. Harshit Singh says, please share your notes as well. Yeah, so all these slides or presentations are also uploaded in the live sessions sheet. Along with the video links, you will also get those presentation links, so you can access all those presentations or notes from there.
Sir, I mean, like if you have handwritten notes or something similar to that when you have also watched the lectures, right? So
Hand
something like
handwritten notes, I don't have those handwritten notes. I mean, we upload whatever we teach during these live sessions. So this slide that you can see, these presentations would be uploaded, and you will get links for those.
okay, okay, got it. I mean, like if you have any structured form of content, because I watched the lectures, but I didn't make notes out of it. So
No, 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 those we don't provide. We provide the slides that we use during these live sessions.
okay, okay, got it. Thank you, sir.
Now question 3. For document classification and summarization, it is important to look at the important sentences and important words. What kind of attention mechanism is required for encoding documents? So there are 4 options: hierarchical, ungraded, sequential, unordered. What kind of attention mechanism is required? Dr. R. Katishwaran says option A. Okay. Anyone else? So the correct answer here is hierarchical attention is required for document classification or document summarization. So the reason for this is that document can be thought of as a sequence of sentences. A sentence is a sequence of words, but a document is a sequence of sentences. So for example, this is one sentence, this is another sentence, this is third sentence. So document can be thought of as a sequence of sentences, and each sentence is a sequence of words. So within each sentence you will have several words in some order. So this is also, each sentence is also a sequence of words. So first we need attention layer for each sentence, and so this attention layer will encode each sentence. Now for this sequence of encoding vectors, this is the first one, this is the second one, this is the third one. Now we need one more attention layer for this set of sentences or sequence of sentences. So that's why it is called hierarchical encoding. The first level 1, this is the level 1 attention, and this is the level 2 attention. So the first level of attention is for individual sentences, and then the second level of attention is for the sequence of, first level of attention is for individual sentences, and the second level is for the sequence of sentences. So that's why we need hierarchical attention for document classification, but for single sentence we don't need hierarchical. For single sentence we will need only one level of attention, but in case of document hierarchical attention would work better. So option A is the correct answer. Now question 4. If you need to design a model for transliteration, which is writing a given input word in another language, then which of the following steps will you use? Option A says CNN is used to encode. Option B says CNN is used to decode. Option C says CNN is used only to decode. Option D says RNN is used to only to encode, and option E says RNN is used to perform both encoding and decoding. So for the task of transliteration, which steps will you use? Arvind Vishnu Vartla says option E. Okay. Dr. R. Kotishwaran says option E. So the correct answer here is option E, that RNN is used to perform both encoding and decoding. So the task of transliteration is to write a given word in some other language. So for example, if I input the word India, so in English, so if I want to transliterate into, for example, Bengali, so the same word will be written but in Bengali alphabets or Bengali letters. So the Bengali word is also spelled as India, just that the Bengali letters should be used to write the word India. So for this task, so each character INDIA would be input to each of the time steps individually, and in the output also each character would be given as output by the decoder. So it is basically sequence to sequence mapping. So the input is this India in English and output is this India in Bengali. So the input is also a sequence, output is also a sequence of characters. So to encode we need RNN, and also to decode we need RNN, because both input and outputs are sequence of characters. So that's why we only need RNN, we don't need any CNN layers. So for both encoder and decoder we need RNN. Now question 5. Consider the above encoder decoder model. So this is the encoder decoder model, this is the encoder, this is the decoder. Identify the function to compute the encoder. Input is xi, so this input is xi, this image is xi, and identify the function to compute the encoder. What will be the output of the encoder? So this is the output of the encoder. What is the output of the encoder? So there are four options. S0, we assume S0 is the output. So S0 equals CNN of H0. Option B says S0 equals RNN of XI. S0 equals RNN of CNN of XI. S0 equals CNN of XI. So this output comes from here. So this is the S0 that comes out of encoder and goes as input, as the state for the decoder, initial state for the decoder. Arvind Vishnu Bhatla says option D. Pilla Rohini says option D. Anyone else? The correct answer is option D. S0 equals CNN of XI. So as you can see, this is for image captioning. So the input is only one image. XI is the image input, and this goes as input to the CNN layer. So the output of the CNN would be CNN of XI, and that goes as S0 to the decoder RNN. So S0 equals CNN of XI. This is the function that the encoder computes, and then this S0 goes as input, goes as the initial state of the decoder RNN to decode the caption for the image. Now question 6. For the same task of image captioning, the figure is also same that we have seen in the last question. What is the output of the decoder now? So there are four options. What is the output of the decoder? So this EYT hat, this basically means that YT, the output of the decoder, is in each time step. For example, for the first time step, the output of the decoder is a probability distribution. So the over YT hat. So E of YT hat basically means the value that we sample from the probability distribution of YT hat. And this EYT hat would go as input to the next time step. So this A goes as input to the next time step. So this is the E hat. Then man goes as input to the next time step. So that is the EY hat that we sample from the output of the probability distribution of YT. Dr. R. Koteswaran says option C. Okay. Option C is ST equals RNN of ST minus 1 EYT minus 1 hat. Okay. Pilla Rohini says option D, which is ST equals CNN of ST minus 1 and E of YT minus 1 hat. And Arvind Vishnu Bhatla says option B, which is ST equals CNN of ST comma E of YT hat. Okay, so I've got 3 different answers in the chat. Anyone else? The correct answer is option C. ST equals RNN of ST minus 1 comma E of YT minus 1 hat, and the actual probability distribution output is probability of YT given YT minus 1 comma I is the input image, equals softmax of VST plus B. V and B are weights and biases here. So in decoder part we don't use CNN at all, so this is for image captioning. So the output is a sequence of words here. So the decoder only contains RNN, so option B and D cannot be correct because both B and D contains CNN, but we don't need CNN for decoder part, we need CNN for the encoder part to encode the image. And once we encode the image using CNN, then we just need RNN to produce the sequence of words as the caption for the image. And so ST is the state that is generated at time step t uh, which will take the state of the previous time step and the input at that time step. So the input at that time step is basically the output of the previous time step. For example, this A is the output of the first time step, so this goes as input to the next time step. Similarly, man goes as input to the next time step. So the input to the time step t is the output of the time step t minus 1. So that is why the input is e of y t minus 1 hat, which is actually the output of the previous time step. So RNN takes these two inputs. RNN module would take these two inputs, st minus 1 and e of yt minus 1 hat, and the output is generated from a probability distribution of the output is generated from a softmax function using this st. So st goes through this weight and bias v and b. So v st plus 1 is computed, then we take the softmax to compute the final probability distribution for the output of the tth time step, which is yt. So option C is the correct answer here. In option A, it says that RNN of st comma eyt hat. So this st and eyt hat, these two are not correct. So it should be st minus 1. So st is generated from st minus 1 and input of that time step, which is the output of the previous time step. So it should be e of yt minus 1 hat. So that's why option A is also not correct. So option C is the only correct answer here. Is there any doubt in this question? Okay, we can move on to question 7. Attention can be used on the three options: only on image input, only on text input, both image and text inputs. Arvind Vishnu Bhatla says option C, both image and text inputs. Pilla Rohini says option C, both image and text inputs. Okay. Dr. R. Kotishwaran says option C. So the correct answer is option C, both image and text inputs. So in text inputs, in case of text inputs, attention tells you which part of the text you should focus more or give more importance for your task, whether it's text classification or sentiment analysis or summarization. So which part of the text you should give more attention. Similarly, in case of image inputs, we can also use attention, which is also taught in the video lectures, that if this is the image, so the image might contain a lot of pixels, a lot of objects, but using attention we can infer which part of the image is more important, whether this part is important, whether this part is important, which part is more important for your task. So the task might be classification of a dog or a cat, or the task might also be how many persons are there in this image. So for that also you need to the attention will tell you which part of the image the persons are. So based on that you can count how many persons are there. So in case of images you can also use attention to focus more on those pixels which are of higher importance than the others. Now question 8. Consider the dimensions of different components of an input gate in a LSTM unit. So the one LSTM for to compute the input gate of an LSTM unit, you need these four vectors or matrices: xt, ht minus 1, wi and ui. So this wi and ui, these are two weight matrices, and xt and yt minus 1 are the xt is the actual input for the time step t, and ht minus 1 is the memory state from the previous time step. And what will be the dimensions of the input gate it? So once you compute this input gate using this xt, ht minus 1, wi, ui, what will be the output, what will be the dimensions of the input gate it? Arvind Vishnu Bhatla says option B, which is 150 by 1. The input gate, the expression for the input gate it is sigma of ui xt plus wi ht minus 1 plus b. So the b is the bias term, so we can ignore bias for now. Bias doesn't have any say on the dimensions of the output. So ui xt and wi ht minus 1, and then we compute the sigma of that. So sigma would not change the dimension of the of this matrix. So we just need to compute what will be the dimension of this ui xt or wi ht minus 1. So the dimensions for these four matrices are given. Xt is xt belongs to r to the power 50 cross 1, and ui belongs to r to the power 100 cross 50. So this is 100 by 50 and this is 50 by 1. So multiplication of these two matrices would give you a matrix of 100 by 1. So similarly we can compute it for the next matrix multiplication, which is wi ht minus 1. So dimensions for wi is 100 into 150, that is given here, and dimensions for ht minus 1 is 150 into 1. So if we multiply these two, it has to come 100 by 1, otherwise we cannot add these two matrices. So if we add these two matrices, the final matrix would also be of dimensions 100 cross 1, and sigma function, this sigmoid activation function, would not change the dimensions of the matrix. So the final output would also be 100 cross 1. So option A is the correct answer. IT belongs to R to the power 100 cross 1. So A is the correct answer. So these were the questions that I wanted to discuss in this live session. And now if you have any questions or queries regarding any of the questions that I discussed today, or any other topic in this week's content, then you can ask me now. So if there are no other questions or queries, we can end this live session now. Thank you everyone for joining. Thank you everyone.